we are now going to focus on finding the derivative of a function without using first principles. So we're going to apply the rules for derivatives. So I'm going to explain the rule to you folks. I'm going to explain the form of that rule. And as long as you can rewrite what it is that you want to differentiate to resemble that form, you'll be fine. Then you can differentiate it. If it does not take on that form, there's a little bit of work for you to do. Now we're going to also look at questions that was given to us by Jessica Malungana and Kotso Mokoatle. Okay, so Kotso and Jessica, I hope that you guys are nailed tight in front of your screen and watching what we're going to teach you. Let's have a look. The rule that I'm going to talk about is referred to as the power rule for derivatives. It says the following. It says if you have a function f of x, that function has a coefficient in front of an x, so it's something multiplied by x, and there could possibly be a power over the x. So an example of that would have been 2x squared, a half x to the power 2 over 3. Yes. Now you've got to know your exponential laws and know them very well. So what I'm going to do, I'm going to start with easier examples, and then we're going to move into the difficult ones the moment you're ready to differentiate. So if this is given to us, then the power rule says that the derivative with respect to x will be whatever is there remains. Okay, that is still there. But that old power, the power n, comes down and it multiplies with the existing coefficient. The new power for the derivative will be the old power reduced by 1. So let's see again. That's the coefficient, that's the power. This is the thing we want to differentiate. The moment we have it in this form, remember, this is the form in which it has to be rewritten. Whatever is given to you has got to be given to you in that form. If it is not in that form, you panel beat it a bit and you get it into that form so that you can apply the power rule. What does the power rule say? Well, let's have a look. The old power comes down, it comes down and it multiplies with the existing, the ax. So n times ax. The new power here is this old power reduced by 1. So a quick example just to show you how this works is to say f of x is 5x to the power of 3. Now folks, can you see it does take on that form? It has the form ax to the n. A is 5, the x is there, and n is indeed 3. So if I now differentiate that, now I'm going to say this slowly. How do we say this? We say the derivative of f with respect to x. Okay, so we're going to differentiate with respect to x. And I'll give you another example now to show you why that's important. Okay, so if I differentiate, remember what the rule says, the power comes down. So it's 3 times the existing 5 that's there, that component. X, the old power was 3, and I reduced that power by 1. So now it's just a bit of cleanup that I have to do. I've got to multiply the constants and subtract the power. So my final result here will be 15x to the power of 2. Now folks, please, the rule is not very complicated. But of course, we know it's not complicated. So we're not going to give you easy stuff like this to differentiate. We want to know, can you remember your exponential rules? Can you divide things into one another? Do you know what a rational power is? Okay, so let's build on that. I've got my example 2 before I go to the examples from Jessica and from Kotso. So example 2, Remember I said we're differentiating with respect to x. So if I choose, let's go for a fraction here, 3 over 2. Let me just get rid of that x. I forgot what I wanted to do here. So I'm going to change that to an a for now. Let's just make it a b times x to the power. And let's be nasty. Let's make the power of the x a half. So I've got two fractions that I threw in there. The number in front of the x is a fraction, and the power of the x is a fraction. Okay, but I also threw a b in there. Okay, now the question is, find f prime x. Find the derivative of f with respect to x. Some teachers will call this f prime x. Nothing wrong with that. It's another way to talk about that. So if I now want to find this derivative with respect to x, this thing is not an x. So I treat it as if it is a number. It's representing something that has got nothing to do with the x. So it forms part of the coefficient of x. Okay, so let's have a look. The coefficient of x is still 3 over 2 times b. Now remember, the half has to come down. So it is a half multiplied by what was in front of the x. The old power of x was a half, and now be careful. I'm going to take that old power of a half and I'm going to subtract 1 from it. Okay, so that becomes minus 1. Now if I want to look at or simplify that, it's quite easy. The coefficient is going to be very easy. It's 1, remember, if you have a fraction times a fraction, top times top, bottom times bottom. So 1 times 3 times b is 3b, 2 times 2 is 4. And now the x, a half minus 1, folks, we all know we don't need a calculator for that. That is minus a half. And this is where your exponents kick in. Remember your exponential law. If a power is negative, you make it positive by inverting the base. Now the base there is x. So if I want that power to be a positive, I must write it as 1 over x to the power of a half, and then I bring the half back. Remember, a half in the power is a root. So this is what you need to recall. First of all, you need to recall that if you have a to the minus m, it's the same as 1 over a to the m. Okay? That will take care of the negative. If this is a to the power of a half, anything to the power of a half is the root of that thing. And those are the two rules that you're going to draw on from exponents. So let's go back and let's finish this. 3b over 4. First of all, the x goes to the denominator. Now remember, I'm multiplying here. So the x goes into the denominator. What did I do? I said x to the minus 1 is 1 over x. And now I'm going to bring the half in, and then it becomes 1 over the square root of x. So folks, you can see, even though the rule is very simple, it comes with baggage from grade 11 and grade 10 in the form of your exponential laws. You have to make sure that you are very fluent in your exponential laws before you can do derivatives with funny powers like that.